Okay, guys. So we're on the last buoyancy / Archimedes problem. So the equation for buoyancy, of course, is found by Archimedes. Okay, so part A asks us to do a free body diagram. So what I've done is I've done a free body diagram separately for the iron ball and the styrofoam block, and that's what you see on the top there. So both of them are going to experience buoyancy and weight, their own weight. How they're connected is by this cable, so they share that tension force. So the styrofoam block, S will denote styrofoam, so the mass of the styrofoam by its gravity, its weight, and he'll experience some styrofoamy buoyancy. And then his tension hanging onto this iron ball. And again, the iron ball is also going to experience buoyancy, and it's going to experience its own mass. And again, that tension force, that's what's connected these two. And so the problem asks us to do this all in terms of the densities of water, styrofoam, and iron. So we want to express first these masses in terms of the density, because we assume those densities are known. We're told the dimensions of these guys. The radius of this ball is r. The length is the cube. All three sides are L. So very easily we're able to find both the weights. And so that's good. So because what we're asked to find is actually r expressed in terms of all these. So I guess we could say r is not exactly known, but we want to express this problem in terms of r to find it. So we're gonna need him in this volume. So that's exactly what we do first. We're gonna write the mass of the block and the mass of the ball. And so we say rho s times L to the third. So the weight is the entire weight. It's not just the weight underneath the water. It's not just the displaced weight. It's, the gravity is gravity. If I'm sitting in water and I'm bobbing up and down, that doesn't change my weight, unfortunately. So his weight's always his weight, just like you guys have always been doing. So density of styrofoam times L third. Density of the iron times 4/3 pi r cubed. Okay, but the buoyancy